quick, but hopefully I'm explaining it slow enough and you're getting it. If you're not getting it, please do rewatch the video, please take notes, and please utilize outside resources as well. I understand that I might not always be the best at teaching a particular subject, or sometimes it takes another person hearing it again from somebody else to see this. Coding is not necessarily easy, but once it clicks, and a lot of it is just repetition. So that is it for this video. We've started to tie everything together. Now from here, we're going to move into what are called functions and build upon all of this. So I'll catch you over in the next video on functions. All right, let's talk about functions. Now, functions are what I like to think of as mini programs. It's like this organized block of code that you define, and then you can call it later, and it makes it a lot simpler than typing everything out. So it's a lot easier to visualize this than me to just talk the theory of it. So let's go ahead and let's gedit our script again, our script.py, and then we're going to ampersand this one this time. And we should have our Python script from before. I'm just going to scroll down to the bottom, and I'm going to add in a new section here, and that section is just going to be called functions. So if we want to print out, we can print out a new line to kind of put this together. And then maybe when it's all said and done, we can print a function or make a function that just prints and make it a little bit easier for us. So we're going to print a new line here, define functions, and maybe we'll just print out something that says, here is an example function. So this is really just going to define the area. If we save it, while you're typing yours, I'm just going to print mine. So we'll python3 script.py, and you see we've got the new line here, and we see here is an example function, and we just start from here. So let's take a look at a function using something that we've already done before. So we've got this section here, and we've got name, age, GPA. We're going to kind of reuse this and just print my name is. So let's go ahead and reuse this. We're going to say function here, right? So we're going to define kind of a who am I. So we're going to define this, and then we're going to do 2 parentheses and then a colon here. So it's going to look like this. And what's important now is that we use indentation. Now, we haven't had to talk about indentation to this point, but Python is very, very critical on utilizing indentation. If you don't use it in the right places, then your program will not function. So it's very important to know when to use indentation and to indent properly. So to indent, I'm just going to tab here, and I'm going to redefine everything again. So we can just say name equals Heath, and we can just say age equals 30. Type that wrong there. And then we can just copy this print right here. So we don't have to type it all out again. Just copy and paste it. And you can see define who am I. And we're going to define in this function a name variable, an age variable, and then we're going to print this out. So if we were to just go ahead and save this and print this, nothing's here. All we've done so far is just define this function. We have done nothing to actually call it or do anything. And let's make a note here that this is a function, right? So when we get down towards the bottom, let's go ahead and just try to call this function. So to call a function, all we got to say is who am I? And let's go ahead and save this, run it again. And look, it says, my name is Heath and I am 30 years old. Well, what's happening here? Okay, so we're defining a set of things to do, right? This is a mini program. And inside this mini program, we've defined our variables, and we defined an action here to take, which is printing out this string. So what it's doing is when we call this, it's saying, hey, I'm going to go ahead and take all this, and I'm going to run this program and give you the result. Now, what's important to note is whatever is stored in these variables here is only stored there inside the function. If we were to print age, from the last video, it should still be 32, I do believe. So let's print, and you'll see it's 32. Even though we declared age up here as 30, that only lives inside this function. So I'm going to go ahead and delete this. So again, everything is living inside this function, and it's a mini little program that we have here, and we just call it at a later time. So let's go ahead and build out another function, and we can kind of start to make sense of this. So let's start with adding what are called parameters, and we'll just do adding parameters here. So let's make a function, and this function is called add 100, like this. Okay, and then the parameter I'm going to actually add inside, instead of giving empty parentheses, I'm going to add in something called num. It's just going to be for number. And then we're going to go ahead and use our colon, hit enter, do a tab, and then what I want to do is I want to print number plus 100. So what am I doing here? I'm taking a number and I'm adding 100 to it. So my function of adding 100 makes logical sense. Okay, so what's going to happen then if I say add 100 and then I specify a number in the parameter? Well, I'm going to say, what if I want to add 100 to 100? Well, then I should, in theory, print out 200, right? And there you go. We have successfully printed out 200. So we can build upon this even more. So what if we want to use multiple parameters? Okay, let's say we want to, let's do multiple parameters. And we want to define an add function. We're just going to make an add. Even though it's built into Python, we're going to make our own. So we're just going to say add x and y. So now we have two parameters here. Okay, we're going to add our colon, make sure we indent, and then we're just going to say print x plus y. Now, if we go in and we add 7 and 7, we should get 14. And there's 14. So hopefully this is starting to make sense. All we're doing is building these mini programs, and we can have no parameters, as we saw up here. We can have single parameters or multiple parameters, depending on what we need. So let's go ahead and build a couple more out just to make sense of it. So what if we wanted to define multiply? And we'll just say xy again. What do you think that's going to look like? Well, instead of saying print, what if we say return? I'm going to throw something new at you. I'm going to say return x and y. Okay, now what happens if I call multiply and I say 7, 7 again? What happens here? Let's go ahead and save it. Well, nothing happened. We're not printing out to the screen. All we're doing is returning. So when I'm pulling this multiply in, it's returning a certain number. So I'm calling it here, and it's saying, hey, 7 times 7, that's 49, but I have no idea what you want me to do with it. Now, I could say print multiply here, and then we can see what happens. And now you see it's 49. So the return feature just allows us to return the number that is back to us, right? We don't have to always print it out if we don't want to. We can store it for later. So that's what we can do here. So we don't always have to print it. We can return the number and then call it later. So that's one way of looking at it. Let's do one more. How about we define square root? And we only take one number here. So how would we do the square root of something? Well, let's go ahead and just print out x. And then we're going to do by 0.5. Remember the exponent with two multiplications here. And then we're doing the square root, so we're going to take 0.5 instead of squared, which would be 2, right? So we're taking the square root, do 0.5. And let's take an easy one. Let's return the square root of 64. So let's say square root of 64 and see what happens. And it returns 8 for us. Now we can make that an integer if we want to and go from there. But that's just a nice base example. So lastly, I mentioned that we can make a function for a new line because we've been sitting in here and we've been just typing print, and I am slow at it. I have to sit here and think about it, and then I find the correct letters, and this is how you print new line. Okay, I'm not the best at it, but what if instead we just did something like define new line, and then we just put this here. So then we can just call new line from here on out. We could say new line, and then when this prints, it'll print out a new line. And while it's the same kind of length-ish of this, we don't have to type in these special characters, look for them. We could even shorten this to like NL, something like NL, and then make it really simple. And then we save time. And this is where these programs come in and they save time. So good example of a use of a function. So I'm going to save this. If you want to use this for moving forward and going on in the next videos, absolutely welcome to. So if you're following along, go ahead and just leave your text editor open, and I will catch you over in the next video as we start to talk about Boolean expressions. Welcome back. So now we're going to discuss what are called Boolean expressions. And we can go ahead and just type this right into our text file. If you don't have your file open with gedit, go ahead and get your script.py open. And what we're going to do is we're going to just put in here Boolean expressions. And now when we say Boolean expressions, we can just think of this as true or false. So let's go ahead and print our new subject line. We're just going to call these Boolean expressions. And from here, let's start defining those. So let's say we have Boolean expression 1. We'll just call the variable bool1. Now let's just set that equal to true. Okay. And let's give an example of that as well. Let's just say boolean2 equals, let's say 3 times 3. Now, what does 3 times 3 equals? Well, that equals 9. So we can say equals equals to mean something equals something. And so this number equals this number. So 3 times 3 is 9, which equals 9. So if we take this expression and we say 9 equals 9, it's going to return true. Let's do a couple more. So we could say boolean 3 equals false, and boolean 4 equals 3 times 3, and then we can say does not equal 9. Well, that's not true, right? So that's false. So if we were to print these all out, we could say print boolean 1, boolean 2, bool 3, and bool 4. Okay, and let's also print the type so we know about this. So we say print type, and let's take a look at what this looks like. So once you have that all written out, go ahead and just save this. And go ahead and run your file. And you can see that it came out exactly how we thought it would. So we've got 4 variables, and they're all Boolean expressions, right? So we've got true, this equals to true, this is false, and this is equal to false. So we see true, true, false, false when we print those all out. And then when we want to look at the type of the variable, so we say, hey, what's stored in here? Inside this variable, what's stored is a Boolean. Now, please do note that there is a difference between true and true. One is a string and one is a Boolean. So if you were to set Boolean 5, for example, to true, and then you printed the type of Boolean 5, then you're going to get a different result here. you're going to see now that the type is a class of string. So big difference here. I'm going to go ahead and just delete this. So this is just an overview of Boolean expressions. We're going to use this later on, and you will see it again when we get into exploit development, but you're going to see certain things, especially when we get into loops as well. So once we start getting into looping and we talk about that, it'll make a little bit more sense. But you want to know sometimes if something is true or if something is false. Or when we get into conditional statements, if something is true, then do this. Or if something is false, do this. We haven't gotten quite that far yet, but we need to introduce the concepts before we can build upon it. So what we're going to do in the next video is we're going to build upon these even more. We're going to take relational operators and these Boolean expressions and kind of combine them and start building upon it. And then once we get this all put together, it'll all start making sense. So for now, all you need to know is when I say Boolean expression, all I'm thinking about is true or false. So we'll build upon that in later videos. Okay, let's build upon where we just left off with the Boolean expressions. So now let's talk about relational operators and Boolean operators. So what do we mean when we say operator? Let's go ahead and just add a new section here, and we'll just say relational and Boolean operators. If you want, you can go ahead and just put a new line here. So remember, we specified new line in a function. And let's say greater than. Let's define a variable called greater than. And let's just make that equal to 7 is greater than 5. Okay, so we're using a operator here with the greater than symbol, right? And we're also using a Boolean expression because when we say 7 is greater than 5, well, that's going to come back with true. And we could say less than. We could say 5 is less than 7. And that's also going to return true. What about greater than or equal to? We can say 7 is greater than or equal to 7. And that's going to return true as well. And then if you can think of less than or equal to, it's going to be very similar. We say 7 less than or equal to 7, and that's also going to be true. So if we were to print all of these out, which we don't have to, they're all going to return back true. So there's other things that we can add in here. So what if we bring in multiple operators? For example, we could say test, and you can call this whatever you want. So what if we say 7 is greater than 5 and 5 is less than 7? So we see here that this is true and this is true. That would make this entire statement true. So we could say true here. If we were to say, let's just call this test and 2, we were to say 7 is greater than 5, which is true, and 5 is greater than 7, well, that's not true. So this whole statement is going to be false because we're going to say and. And is very important here, right? What if we were to say something like or, though? If we were to say, let's test out or, we could say 7 is greater than 5 or 5 is less than 7. Well, this is going to return true. And if we were to do the same thing as we did above, where we say test or 2, and we say 7 is greater than 5, or 5 is greater than 7. Forgot my parentheses here. And this is also going to return true. Why? Because only one statement has to be true here for these both to be true. In the instance of and, both statements here have to be true in order for it to be true. If one of them becomes false, the whole thing becomes false. in the sense of or the case of or, if both are true, it's true. If one or the other is true, then it's true. Both have to be false for it to actually return false. Okay, so you can print these out as well to test this out. The other thing that we can say is we could say something like test not. We can say something like not true. And guess what not true is going to be? False. And if we said not false, then that'll be true. So these are the ones that can start to kind of get confusing. So again, my recommendation is to make good notes on this and then go out and study it. And there are true false charts. Let's just see if we can Google one quickly. There are true false charts online. We could say true false chart Python. And go to images. And we can see truth tables is what they're called. So if A is true and B is true, the A and B are true. If A is false or true and B is false, then they're both false. False true is false and false false is false. So in order to have a truth table for and, everything has to be true. So if we search truth tables, that might give us a better chart here. And then you get something sort of like this, where you have and, where you see true, true is true. You have or, where true, false is still true. And then XOR we don't have to worry about right now. So take good notes on these. Make sure you understand them. We're going to continue to build upon them over time. Really, all you have to think about, though, is you have to think about Boolean operators and these expressions. And the most important things to take away from this are not just the true and false, but the greater than symbols, the less than symbols, all these different types of operators that we can utilize here. And that we can also utilize things such as and, or, and not as well. So we're just adding more tools to our toolkit and more things to think about. Where Python is important when it comes to pen testing is not necessarily being able to develop. And I've said this before, I'm going to say it again. Being able to read and understand what is going on is super important. Being a developer, not as important. So as long as you see these things and you see a true, or you see a statement like this when you're reading code, and you say, hey, I know that's a Boolean operator. I know it's true or false, and I kind of understand the truth tables, right? So that's really what we're after here. So as long as you start getting this understanding and this comprehension, that's really what we're after. So from here, we're going to move on and we're going to go into conditional statements. And that is where we get into something called if, then, else. And we'll have a little bit of fun with those. So I will catch you over in the next video. Now we're moving on to conditional statements. Now, you could think of conditional statements as an if-else scenario. For example, if you go to the store and you want to purchase a drink, and the drink costs $2. Well, if you have $2, you're going to be able to purchase that drink. If you don't have $2, then you won't be able to purchase that drink. That is a condition. So the condition there is based on the amount of money you have. We can take these conditional statements and we can run if else. We could also run if else, and build upon these. Now it'll all make sense when we start putting it together in our script here. So let's go ahead and just do that. Let's make a new line. And let's make a comment here that says conditional statements. And let's start with a conditional statement. So a conditional statement's going to start off looking like a function. So we'll say define. And here, let's make the same scenario where we talked about the money and buying a drink. So we'll define drink, and we'll just say a parameter here of money. Okay, and then let's indent, and let's say if money is greater than or equal to 2, remember we talked about $2 for this drink, then we're going to return you've got yourself a drink. Now, what if we don't have the money? So we could say else, if our money is not greater than or equal to 2, then we're just going to return no drink for you. Didn't mean to capitalize the O there, but I'm leaving it because I like it. So in this situation, we have our conditions set. Now again, if our money equals or is equal to or greater than 2, we're going to get a drink. And if not, we're not going to get a drink. So it could be anything else, right? So what we can do now is, since this is just returning and not printing anything, we can print out something like drink, and then we specify the amount. So if we have 3, we should return one thing, and if we print drink here with only $1, we should return another. So let's go ahead and save this script. And I didn't put this with an ampersand, so I'm going to close out and make sure I do that next time. And what we're going to do is we're just going to go ahead and python3 script.py. And you can see down here, we go back and let me run this script with the ampersand. You can see that we did a drink of 3, which we were expecting to return, you've got yourself a drink. And we did a drink of 1, which we were expecting to return, no drink for you. This happened just the way we thought it would. So we can build upon these conditional statements. Let's talk about a different scenario with multiple parameters. Let's say that you are an adult, and here in the United States, if you're an adult and you want to have a drink of alcohol, that requires you to be of age at 21. So in order to purchase alcohol, you have to be 1, of age, and 2, have money. Now, if you don't drink, that's perfectly okay. This is just an example scenario. So here, let's say we wanted to buy alcohol. We have to meet that age requirement of 21, and we have to meet the requirement of money. Now, we could be in a situation where we meet the age requirement, but we don't meet the money. Or we could meet the money requirement, but we don't meet the age requirement. Or we could be in a situation where we don't meet the age requirement and we don't meet the money requirement. So let's set this up to think through this and how these scenarios could play out. So let's define alcohol here. And we need 2 parameters. We're going to say age and money. So first statement here is going to be our leading if, and we're going to say if age is greater than or equal to 21, because we need that condition to be true, and our money is greater than or equal to 5. So we'll say a drink costs $5. We're going to return, we're getting a drink. Okay, now, since we're going to have multiple conditions here, we're going to introduce something called else if. Else if here is written like this, ELIF. So else if our age is greater than or equal to 21, and our money is less than $5, then let's return come back with more money. We need another else here because we have another condition, right? So we're going to say, what if our age is less than 21 and our money is greater than or equal to 5? Well, we're going to return, nice try, kid, because we're not old enough to purchase this drink. And then lastly, in our else scenario, if we are not meeting any of the conditions above, which means we won't have the age, we won't have the money, then we're just going to return, you're too, if I could type, sorry, you're too poor and too young. So let's go ahead and run this a couple different times. So let's go ahead and print out alcohol, and we're going to give our 2 parameters. So let's say 21 and 5. Let's print out again alcohol, and let's give a parameter of 21 and 4, And then let's print out one last time of alcohol, and we'll say that we are 20 and 4. So we should meet a few different conditions here, right? So at 21 and 5, we should return we're getting a drink. At 21 and 4, we should return come back with more money. And at 20 and 4, we should return you're too poor and too young. Now, if you want to add in a fourth condition here or a fourth print statement and you want to return the nice try kid, you're more than welcome to do that as well. So go ahead, hit Control S or save your script out. And then let's go ahead and run it. And you can see we return exactly what we thought we were going to. We're getting a drink, come back with more money, and you're too poor and too young. So this is it for conditional statements. Hopefully this makes sense. Again, our conditions are based on certain items, right? So money here, for an example. If we have the money, we're getting a drink. If we don't have the money, we're not getting a drink. And then we can build upon that. We can have multiple parameters here. So if we're not old enough to buy a drink, or we don't have enough money to buy a drink, or we don't meet any of these scenarios, different things can happen. What you need to be thinking about as a developer, programmer, or even writing these scripts is all the scenarios that could happen in these situations. You got to think of the logic behind it. So when you're building out a script, or you're building out your first program, you need to think logically. If I make an if statement or a conditional statement, what's the logic behind it? So a lot of times, for example, in this scenario, we might have thought, okay, well, if I don't have the age or the money, okay, but you got to think about what if I do have the age but not the money, or I do have the money but not the age. So you have to think through everything in your head and make sure that it's all clicking. And this just takes repetition and just sitting down. The best way is with sitting down with the pen and paper and not writing this in code form, but just writing this in a sense that makes sense to you, thinking through it logically, and then writing it out in code. So from here, we're going to go ahead and move on to list in the next video. So once you're all caught up here, let's go ahead and move right over there. Okay, now let's talk about lists. So lists are data structures. Now these data structures are changeable. We can reorder them, put them in a list, right? So they're just a group of elements. And when you have this list, everything inside that list is called an item. And the best way to think of a list is to think that it lives in between brackets. You're going to see other things later on that look like a list, but it's not really a list because of how it's defined. And how we're going to define lists is because they live in brackets. Just like a string might have quotes around it, a list is going to have these brackets around it. So let's make a new line, and let's go ahead and just do something along the lines of lists. And we could just say something like have brackets, like this. Okay. So let's go ahead and make a list, and then we can kind of go from there. So let's define a list of your favorite movies. Now you could put in whatever favorite movies you like in here, and I'm going to put in something like When Harry Met Sally, The Hangover, The Perks of Being a Wallflower. And this is getting kind of long, so I'm actually going to move this over a little bit for us. And we'll say one more. Let's pick 4 movies. We'll do The Exorcist. Okay. And now we have this list. Again, lists just live in brackets. So we've got list item 1, item 2, item 3, and item 4. Okay. So let's go ahead and print these. So if we were to print out something like movies, and we said we wanted to print the first item out of movies, let's go ahead and try to print When Harry Met Sally. So we'll print the first item. So put a bracket around it just like this. We'll print it out and we'll see what happens. So let's save it. And what's it going to return for us? It's returning The Hangover. So item 1 is not item 1 as you see it. So when we talk about items, when we talk about numerical order here in Python, item 1 is actually going to be referred to as 0. So make a note here for yourself that this will return the second item. So if we wanted to return just when Harry met Sally, we would actually put in movies 0, like this. And we could say, returns the first item in the list. Okay, and we can save that. And let's go ahead and give it a go just to do proof of concept, and there you go. So remember that everything starts with 0 and not 1. So when you're thinking about things, let's think about them with 0 as the beginning number. So let's go ahead and do a few more different prints. What's going to happen when we print out something like this? We'll say movies, and we'll do 1 through 3. Do you have a hunch? Let's go ahead and save it. Print it out here, and it will take the list here of starting at 1, and it'll end before 3. So let's say we want to pull a couple items out. The first number that we're going to pull out is going to be the one that we want to start with, and the last number that we're going to pull out is going to be the number where we're going to stop. So the Exorcist is 3, but if we wanted to actually pull down the Exorcist, we would have to pull down 4 here. So if we want to try to grab more than one thing out of the list, we can absolutely do that, but we have to know where to stop. So now we incorporate the Exorcist here. Let's say we wanted to grab everything in a list, and we wanted to grab everything after a certain point, right? We could say something like movies 1 like this, and then we should be able to grab every single thing. And that does pretty much the same thing here.